So as you see here, we actually didn't have a very complicated demand curve, demand function, and total cost function, but still we have a pretty long profit function to start with. And we know that the more complicated the function is, the more likely that we are making mistakes. So the question is there any way that we can simplify this calculation, or at least make those steps, as smaller increments, so as to avoid big mistakes, like as you're writing this long equation? Okay, there is an alternative way to this. That's why here I'm demonstrating another solution to this very same problem. Okay, before approaching to the solution, let's first look at some review. So marginal is the concept of derivative. Marginal revenue is change in total revenue for producing one additional unit of product. Okay, one more or one additional, those are interchangeable. So this is basically means that, change in total revenue comes from change in quantity, right? So say if you gain 1 million more income by producing 1,000 more units, right? Then each additional unit that you produced can give you $1,000. So that is marginal revenue. That's the marginal concept, which is also the derivative of total revenue. So as I previously did the maximizing revenue problem and minimizing cost problem, I was actually reminding this already. So now for marginal cost, that is changing total cost for an additional change in quantity, right? Again, if your total cost increased by 1,000 as you are producing 5 additional products, then each additional products that you're producing on average should give you like 200-ish costs, right? So marginal cost, the cost of producing each additional unit of product, that is the marginal cost, which is the derivative of total cost. So here what we can do is actually we can take a derivative to find the marginal functions, including total marginal revenue and marginal costs. Okay, and then the profit is maximized when marginal revenue equal to marginal cost, and then we can just directly solve for this. Okay, so here are the steps. We need to first work out total revenue, then work out total cost, and then derive marginal revenue, derive marginal cost, and solve for Q. For Q star that equalizes marginal revenue to marginal cost. So just to further explain to you a little bit, why is that? So profit is marginal revenue equal to marginal cost, right? And those are all functions of Q. So now, in order to maximize profit, the first order condition is pi prime Q equal to 0, right? I'm sorry. Pi is total revenue minus total cost. So here, what is your left-hand side? Your left-hand side is actually d pi over dq, right? And don't forget, your pi is total revenue minus total cost. And then it can be separated into derivative of each. That's the plus minus rule, okay? And the first term is marginal revenue. The second term is marginal cost. So that's your left-hand side. Don't forget, it equals to your right-hand side, which is 0. So it's marginal revenue minus marginal cost equal to 0. That is basically marginal revenue equals to marginal cost. Okay, so for this question, solving for Q star will be good enough. And for this one, I normally don't ask you to check the second order. You should, but here, for this class, I just avoid the trouble. Okay, so let's look at the problem. Again, the problem is P equals to 80 minus 2Q. Okay, FC is 50. VC, variable cost, is 2Q squared minus 20Q. Okay. All right. So now, total revenue is P by Q, which is 80 minus 2Q, by Q, which is 80Q minus 2Q squared. And here, total cost is 50 plus 2Q squared minus 20Q, which is fixed cost plus variable cost. So now, marginal revenue is derivative of total revenue with respect to Q, which is 80 minus 2 times of 2Q, which is 80 minus 4Q. And marginal cost is derivative of total revenue with respect to Q. I'm sorry, total cost with respect to Q. That is 2 by 2Q minus 20, which is 4Q minus 20. Right? Now we don't have this long equation to deal with anymore. Instead, we are actually breaking down this equation step by step, breaking down the derivative, right, step by step. So here, the last step, so we work out the marginal revenue, we work out the marginal cost. The last step is marginal revenue equals to marginal cost, which is 80 minus 4Q equals to 4Q minus 20. So we move minus 20 to the left-hand side, change that into plus 20. We move minus 4Q to the other side, change that into plus 4Q. So the result is 100 equals to 8Q. So Q star equals to 100 over 8, which is 25 over 2. That is 12.5. So here, as you are going down to this equation, is actually the same result, right? So the only difference is here we are just breaking down this long one into two parts, the total revenue one, the total cost one, and we take the derivative of each and we equalize them, which is essentially the same as you are deriving the derivative of this long one and set that equal to 0 to solve for the Q star, which yields exactly the same result. So this is how we do this with marginal, how we solve for profit maximization with marginal values.